In this module, we will look at the IP address format. There are two different types of IP address formats. The first one is known as IPv6, which stands for IP version 6. And the second one is known as IPv4, which stands for IP version 4. The IPv6 is the new format or the new standard that is being introduced to replace the old standard that is known as IPv4. The IPv6, however, is not in widespread use. It is expected that IPv6 would be brought into use over a period of time. The IPv6 overcomes some of the drawbacks of IPv4. But because of the fact that IPv4 is in widespread use, our discussion will focus on IPv4. What is the basic difference between IPv4 and IPv6? The IPv4 is a 32-bit IP addressing scheme, whereas the IPv6 is a 128-bit based addressing scheme. As mentioned earlier, we will focus on IPv4. Here is a typical format of the IP address. Of course, bear in mind we are looking at IPv4, therefore the IP address will consist of 32 bits. A typical IP address is composed of zeros and ones. For the sake of convenience, we have divided this 32-bit address space into 4 parts. Each of these parts therefore would have 8 bits. As such, each of these parts is called an octet. A 32-bit address space therefore is divided into 4 octets. In general, it is not possible to remember or convey IP addresses in zeros and ones. As such, for the sake of convenience, IP addresses are expressed in decimal numbers. How is it done? It is done by converting each octet into its decimal equivalent. Therefore, in practice, we will use the following reference to indicate an IP address. In this case, the IP address would be 175.204.129 and 51. Each of these decimal numbers will be separated by a dot. More importantly, however, the IP address format is divided into two functional components. The 32 bits address space is divided into number 1, a network ID component, and a host ID component. The length of the network ID component will be determined by the class of the IP address. We will learn more about the classes of IP addresses in a later module. There are, for example, class A, B, C, D, and E, the different types of IP addresses that can be found in practice. But before we obtain an understanding of the classes of IP addresses, let us get an initial insight into the network ID and host ID. Let us use the network in this lab to get this understanding. Consider the network that is composed of multiple clients. These clients are connected together using a switch. So we will call them as clients here, C1, C2, C3, and C4. And of course, this is a switch that is in turn connected to a router. The router is connected to the campus backbone, which is a FTDI fiber ring. It operates under the FTDI technology. This is the large fiber ring that traverses the entire campus. The campus backbone is connected to the external world through a router. In the past, this router was directly connected to the national backbone, thereby gaining access to the internet. some changes were made, and now this router is connected to an ATM switch that is in turn connected to the internet. As we can see from this diagram, there are hosts and there are networks. All the IP addresses that are used at Cal State Los Angeles start with the following two numbers, 130, 182. And the two other numbers that are part of the IP format are available for use within Cal State LA. Now consider the address of this particular client. It is 130, 182, 215, 35. And the next client here will have an address that is 130, 182, 215, 36. At Cal State LA, what we have done is we have obtained the address space that starts with 130, 182 and further subdivided this address space by using these two digits into subnets. And in this particular case, this subnet here that is connected to the router is known as the 215 subnet. Therefore, the network address of these computers here are 130.182.215. This simply states that we are in the Cal State LA network and that we are on a subnetwork that is marked by the numbers 215. Within this subnetwork, we have hosts whose IDs run from 35, 36 and henceforth. So if we take the IP address of the first computer, it would be 130.182.215.35. As we can see that the first three components of this address identify the network. Therefore, we will call this the network ID, whereas the last component identifies the host. As such, we will call this the host ID. Here is a brief explanation of the difference between a network ID and a host ID. This concept will become clearer as we discuss IP addresses in more detail in later modules. Here is a website as a starting point to obtain more information on the new IP format that is known as the IPv6. This brings us to the end of this discussion on IP format.